Hello everyone, this is Hitesh Mehta. I welcome you all once again to my channel. In this video, basically, we are going to see how to check whether a number is an Armstrong number or not in Python. Let's get started without wasting any time. Let's get started with the code. Okay, so first of all, this is the code to check if a number is an Armstrong number or not. What is basically an Armstrong number? An Armstrong number is a number in which the sum of the cubes of the digits of its digits is equal to the number itself. For example, the example for this number is 153. 153 is an Armstrong number. Why? Because the sum of the digits. What are the digits here? 1, 5 and 3. What are the cubes of these digits? 1. What is the cube of 5? It is 225. And what's the cube of I'm very sorry, it's 125. And uh what's the cube of 3? It's 27. It's 27. So if you add all the cubes of the digits, you will get 153. That is why 153 is an Armstrong number. Another example is 370, 371. All these numbers are Armstrong numbers. So basically in this video we are going to check, we are going to build a program, we are going to build a function which will check whether a number is an Armstrong number or not. Okay, so let me define a function here. Let's take the name of the function to be an Armstrong. Okay, and let's give n as the n is basically the number, and we'll give it as the parameter. So what I'll do here is to check whether a number is an Armstrong number or not. We basically need the cubes of the digits, and obviously to find out the cubes of the digits, we need to find out the digits of the number. So basic logic behind finding an Armstrong number is to just get the cube of the digits. So let me take any number. Okay, so for any number that will be asking at from the user at the end. Okay, so what can we do? First of all, here I am taking another variable called num, and I am assigning its value to as n. Okay, the original number that is given to me by the user. Now I'll take another variable called sum, which will add up all the numbers. Okay, so sum, because it is a keyword, let us take s only. It will denote our sum. It will what will add here will add the cube of the digit at each step to this sum. Okay, so we'll initialize it as 0 because initially our sum will be equal to 0. Now what we are going to do is we have to find out the digits of each and every number. So what I'll do here is I'll just what how you will find the digit of the last digit of a number. How you will find the digit of the digit, that is the digit at the units place. You'll do is at for finding the digit at the units place, you'll just divide the number by 10 and get its remainder. So here we'll get n modulus 10, and this will give us the last digit. Isn't it so? For example, the number is 23. Okay, so if we'll divide by 10, question will be 2 and remainder will be 3. So basically 3 is the digit at the units place. So in this way we'll get all the digits. For example, what actually is the logic here is, for example, the number is 125. Okay, for example, the number is 125. At the first step, I'll just divide it by 10 and find out the remainder. So the remainder will be 5. Okay, it will give me the first digit. Now to carry out the same process again, I don't want this 5. I want only 12, because if I'll divide 12 by 10, I'll get the second digit, that is 2, as the remainder. 2. So for that, I'll be dividing the original number by 10 at each step. Okay, at each step of this loop. So we'll use here the while loop, because we don't know how long is the number, how long is the number entered by the user. So we'll use while. And how much, for how much time we'll do that? While, uh, till the value of n does not become 0. Till the value of n does not become 0. Okay, so for while not n not equal to 0, what we have to do? Let us take in a variable called digit. What we'll do is n modulus 10. Digit will be equal to that n modulus 10, the remainder that will be getting after dividing the number by 10. Okay, so let's just add that the cube of this digit, okay, to the original variable, that is sum, plus equal to digit ka cube of the digit. Okay, so I'll use the double multiplication symbol, this double asterisk. Okay, so at each step we'll be adding the value of digit cube of the digit to the sum function, to the sum variable basically here. Okay, now what we have to do is, in order to reduce the value, in order to get 12 out of 125, what we have to do here is, at each step will divide, and not only simple division, will use the floor division method, because if we'll simply divide 125 by 10, we'll get 12.5, and we don't want 12.5, we want only 12. That is why I am using the floor division here, and at each step we will divide it by 10, floor divided by 10. Okay, so in this way it will get us all the digits. And yes, we have already added the cube of the digits to the sum. Now at the last step, I'll check if our sum, that is s, equal to the number. Why I am using here num? Why I have defined the variable num here, we have when we already have the value of n? Because here I am changing the value of n at each step. Can you see? Here I am changing the value of n at each step. So n will not remain as it is. It will get changed at each step. That is why I have taken another variable initially and assigned that value to it. Now I'll check if sum, that is our s equal to num, will print just that num is an just a minute, is an Armstrong number. Okay, we'll just print this. Okay, now, yes. And what in the else part? Let me just copy this statement. Okay, and now for the else part, we'll just say print the num is not an Armstrong number. It is not an Armstrong number. So we're here, that's it. That's the code for checking an Armstrong number. Now what we can do, basically we have designed a function here. Now we can ask the value of n from the user. Okay, so n equals to int input, and we can say enter any positive integer of your choice basically. Okay, and now what we'll do is we'll just call the function Armstrong of n. Okay, let's just run this code. See, you can see here It is asking me the value of n. Let's add any Armstrong number first. Let's add 370. It's an Armstrong number. So yes, 370 is an Armstrong number. And now let's check for any non-Armstrong number. Let us add 329 something or any other number. 329 is not an Armstrong number. Make sure if you add any digit, if you add any digits, for example 1, so 1 is an Armstrong number. 1 is also an Armstrong number. Obviously, 1 cube will give you always 1. So 1 is also an Armstrong number. So that's it. That's the code we have checked also. So if you like my video, please give it a thumbs up and subscribe to my channel. Please share it to as many friends as you as possible. Okay, it will be helping you. It will be helping them also. Thank you for watching my video. Stay safe, be happy. Thank you.